There's another plexer for you. The answer is flash in the pan. Alright, so the third problem in this section here, where we're trying to figure out the points at which the graph of the function has a horizontal tangent. Keep in mind that horizontal tangent means that y prime is equal to 0, because tangent lines have a slope, or horizontal lines have a slope of 0, and derivatives are the slope of the tangent line. Okay, well, so again, the question is y prime equals 0 where? And here's the function. Y prime is equal to, we have a quotient, so we're going to use the quotient rule, and the quotient rule is low d high, high d low. So we have low, x squared plus 3, d high, which is 1, so low, denominator, and then d high, derivative of the numerator, multiply or minus high d low, so the numerator multiplied by the derivative of the denominator, d low, so 2x. Low d high d low, and then over low squared. Alright, so this is equal to 0, so y prime is equal to 0 when, again, when the numerator of a fraction, the denominator of a fraction can never make the fraction equal to 0. It's only when the numerator, x squared plus 3 minus 2x times x minus 1, I just flipped it around there, is equal to 0. And I want to go ahead, and this is where the mistakes are made, I want to distribute first before I distribute the minus sign. So 2x times x is 2x squared, and then 2x times negative 1 is negative 2x, is equal to 0. Now we're going to go ahead and distribute the minus sign. Minus 2x squared plus 2x equals 0. We get a negative x squared plus 2x plus 3 is equal to 0. And I certainly don't like to have to factor a polynomial with a negative leading coefficient. So I'm going to go ahead and multiply both sides by negative 1. And so basically I'm changing all the signs of all the terms. X squared minus 2x minus 3 is equal to 0. So I can do that with no penalty. And then I can see it's easy to factor x minus 3 times x plus 1 is equal to 0. And keep in mind, this polynomial here is what y prime is equal to in the numerator. If we go all the way back here, this numerator then is equal to x minus 3 times x plus 1. Therefore, y prime equals 0 when x minus 3 equals 0, and when x plus 1 equals 0. In other words, when x is equal to 3 and when x is equal to negative 1. And I guess we could do that if we wanted to figure out what y of 3 is. Y of 3 is 3 minus 1 over 3 squared plus 3, or 2 over 9 plus 3 is 12, or 1/6. So we have the point 3, 1/6. And also, when x equals negative 1, we have y of negative 1 is equal to negative 1, where is it? Negative 1 minus 1 over negative 1 squared plus 3. And that is negative 2 over 4, so negative 1/2. So we have also the point negative 1, negative 1/2. And so those are the points at which the tangent line to this graph is horizontal. It would be interesting to draw the graph. Maybe I'm probably not super interested in doing this, but I'm going to go ahead and type into my y1 x minus 1 divided by my x squared plus 3, and then I'm going to graph that. And we've got, do we have any vertical tangent lines? No. Any vertical tangent lines? Do we have any horizontal tangent lines here? Yeah, x equals 0. Or sorry, y equals 0. And, oh man, things taking forever to graph. But it looks like the graph, it's not very clear. Okay, so anyway, let's see here. 3, 1, 6. So if the graph looks like this, and then negative 1, negative 1/2. So it kind of comes in like this. Kind of goes down like that. And right here, we have a horizontal tangent line. right there at -1, -1/2. And right over here we have a horizontal tangent line at 3, 1/6. And that's basically what the graph looks like. Again, if the x values get really big in the positive or negative direction, then the function's values are approaching 0 because the denominator's exponent is bigger than the numerator. So we have a horizontal tangent line, horizontal asymptote of y equals 0. Probably a little bit more than you wanted to know about that, but I think it helps to get a picture of what's going on, and that's what we're trying to find. We're trying to find where along the curve the graph has horizontal tangent lines. Okay? So now let's take a look at this next problem, in which we're given a chart, and we're trying to use the chart here to find f prime of 3, and we're given various pieces of information about the function f and also the function g. In part A, we're given that f of x is equal to all this stuff. And so this is kind of new notation for you in a sense, but really it's where you can use the same rules that you learned earlier, in that we're going to use the product rule, the power rule, quotient rule, things like that. And hopefully after these 4 examples you'll see how it works. Okay. So anyway, the first thing we want to do is figure out what is f prime of x. And f prime of x is equal to, remember the constant multiple rule? Well, we have 4 times g prime of x, okay, minus 1/2 times h prime of x, and then plus 1, the derivative of 1 is 0. Okay, so the derivative of 4g of x is 4 times the derivative of g of x, and the derivative of -1/2 h of x is -1/2 h prime of x. Alright, well that means that f prime of x is a function, and this is what the function f prime is equal to. Therefore f prime at 3 is 4 times g prime of 3 minus 1/2 times h prime at 3. Okay, well g prime of 3 from this chart up here is -2, and h prime of 3 from the chart is equal to pi. And I'll let you simplify that, but that's it. -8 minus pi over 2. Okay, I'm going to leave it like that because I don't have any more room. Okay, and then problem B, we have f prime of x equals, here we have the product of 2 functions. Therefore we say the product of 2 functions, the derivative of that would be the first times the derivative of the second, plus the second times the derivative of the first. Okay, so there's the product rule. And therefore f prime at 3 is equal to g of 3 times h prime of 3 plus h of 3 times g prime at 3. And g of 3 from the chart is 4, h prime of 3 is pi, h of 3 is 3, and g prime of 3 is -2. And so 4, I have room here, so I'll simplify it. 4 pi minus 6. Alright, so there you go there. And I'm going to use a different piece of paper for problem C. Okay, so problem C, let's just kind of cruise on over here. We see that f prime of x is equal to the derivative, so low d high, sorry, low d high minus high d low. So 2, there's your low, d high, so the derivative of the numerator, okay, minus high, which is g of x, times the derivative of the denominator, 2 times h prime of x, divided by the denominator squared. That's kind of a mess. Therefore, f prime of 3, let's go ahead and just plug it in. 2 times h of 3 times g prime of 3 minus g of 3 times 2 times h prime at 3 all over 2 times h of 3 squared. And again, from the chart, h of 3 is 3, g prime of 3 is -2, g of 3 is 4, times the 2 times h prime of 3, which is pi, That's easy once you write it all out. And then we have 2 times h of 3, which is 3, and we're going to square that. So another quick calculation here. We've got 6 times negative 2 is negative 12, minus 8 pi all over 36. I'll let you simplify that. We're in calculus now. We don't need to be bothered by simplifying all the little details. But there's your number, and that is C. Okay. And then D, do we have time? Yeah, we have time to do D. Cruise on over here and do that. So let me just make sure I've got room. So D, f prime of x is equal to low, which is g of x, times d high. Now d high is g prime of x minus h prime of x. Remember, the derivative of the derivative of a difference is the difference of the derivatives. Okay. Now minus, and we're going to have to go down here a little bit. So this is all in the numerator. Minus high, which is gx minus h of x, and then times d low, which is the g prime of x. Now all of that is over g of x squared. Okay, therefore f prime of 3 is g of 3 times g prime of 3 minus h prime of 3. Okay, minus, and then we have this g of 3 minus h of 3 multiplied by g prime of 3. Squeeze that in there. And then over g of 3 squared. If I were you, I would be fast forwarding through this because you probably don't need to listen to everything. And then I'll get this done in a couple minutes. So g of 3, and where is that? G of 3 is 4. G prime of 3 is negative 2. Oops, I gotta subtract that in here. Negative 2 minus h prime of 3 is pi. Okay, minus g of 3, again it's 4. H of 3, 3, and then g prime of 3 is negative 2. Okay, and then we have g of 3, which is 4, and we're going to square that. Wow, this is a lot of work. Negative 2 minus pi minus, so we have minus negative 2, so we can do plus 2 times 1. Alright, so that's plus 2 all over 16. And what do we get here? We get negative 8 minus 4 pi plus 2 over 16, which is negative 6 minus 4 pi over 16. We can leave that alone right there. Sheesh, that's a lot of work. Alright, I'll stop the video here and pick it up in the next video.